Welcome everyone, my name's Janelle and I am the UK Specification and Education Manager at Abodo Wood, and I am also the founder of the Chulo CPD platform. We've got an exciting webinar for you today, and it is an absolute privilege to have the firm Henning Larsen present at today's CPD webinar. Before we move into introductions and today's content, I'll quickly run through a few housekeeping notes with you. If this is your first time joining a Chulo live stream, then welcome. Today's session is hosted on the Livestorm platform, and on the right hand side of your screen you'll see both the chat and the Q&A tabs. I really encourage you to use these throughout the session. The chat is a great space to connect with each other, share insights, drop in links, or capture key takeaways as we go. The Q&A tab is there for any questions you'd like to put forward to our speakers. We really see these sessions as a shared learning environment. So don't be shy, jump in and be part of the conversation. Now, in terms of your CPD points and certificates, these will be allocated and sent out to you following the session. Now, it is an honour to be hosting today's event and to welcome a speaker of this calibre. I'll be honest, I had a bit of a fangirl moment when he said yes. Today's keynote comes from one of my favourite architectural practices in the whole wide world, and that's because their work is not only beautiful, but it's deeply thoughtful. Thoughtful to the environment, to materials, and to the people who ultimately inhabit those spaces. So it's a real privilege to welcome Jakob Strømann-Andersen, Director of Innovation and Sustainability at Henning Larsen, to the stage. Jakob's work sits right at the intersection of engineering, architecture and technology, exploring how truly integrated design can shape healthier buildings and cities. He brings extensive international experience across projects focused on climate adaptation, sustainability and intercultural design, and also works closely with Danish authorities on the development of future building regulations. What I personally love about Jakob's approach is how deeply data-informed it is. From healthy materials and circular design through to wind simulations and microclimates, his work is all about embedding bio-based materials, reducing CO2, and designing for biodiversity and nature-positive outcomes. Jakob manages the unique industrial PhD program at Henning Larsen, which co-hosts PhD candidates from co-sponsoring institutions in various R&D projects based on different Henning Larsen case studies. Topics include integrated acoustic simulations, lighting design and learning environments, design for disassembly of facades, and anthropological studies following on knowledge, dissemination in shared spaces. And you really see this come to life in the work, from Fallethby in Copenhagen, set to be the city's first all-timber neighbourhood, to the bestseller logistics hub in the Netherlands, which will be Europe's largest timber logistics centre, as well as projects like Falbali School and the world of Volvo in Sweden, where materials like straw, seagrass and timber are reimagined in a really contemporary way. It's no surprise Henning Larsen has been recognised by Fast Company as one of the most innovative companies in the world. And aren't we lucky to be able to dive into all of that today? Joining Jakob a little later for the Q&A, we also have Daniel Gudsell, founder and managing director of Abodo. Daniel is the founding director of Abodo Wood, a New Zealand-based family-owned company in an industry where many exterior timbers are still sourced from unsustainable old-growth forests. Daniel has spent over 20 years leading a movement towards something better, crafting timber solutions that are high-performing, beautifully designed, and that actively protect the world's irreplaceable forests. So we're incredibly lucky to have both of them with us today. But to start us off, Jakob, I'm going to hand it over to you.
Thank you, Jay. Thank you, Jay, for the very, very, very nice introduction. I think I couldn't have done it better by myself. So I'm very, very honored. And also very honored to be here today, invited by the Abodo. We have a lot in common, especially around bio-based materials, timber and wood. Short introduction, my name is Jakob. I'm heading our R&D department here at Henning Larsen out of our mothership in Copenhagen, Denmark. I've been with Henning Larsen for around 17 years. Have actually a trained background in engineering, civil engineering, and so I have a right brain and I understand a lot of numbers and data. And then I trained my left brain, being with this design studio for around 17 years on colors and shapes and architecture. I have put a presentation today. I have a lot of slides, but not so much text, mostly images and videos. But there is some data in it, and I think it's also good to discuss. And I also promised Daniel to discuss what is happening in Europe, and especially in Denmark around the CO2 and the carbon from a legislation point of view. So I will also dive into that. But most of all, I'm looking forward for our Q&A. So please also add in the chat a lot of good questions and a lot of discussion. That is always what I'm looking forward to. And also, just to be honest, we don't have any project in New Zealand at the moment. So if some of you have opportunities, don't feel free to reach out, and we will love to go to New Zealand. There's a lot of same culture across New Zealand and Denmark and Scandinavia. Short introduction, Henning Larsen is part of the Ramble group, big engineering group, but we are heading the architect, landscape and urbanism, but we have support from the engineers on energy, water and buildings. And just for everyone to let you know that we are a foundation-owned company. We are not equity-owned or partnership-owned. We are like, maybe you know, Patagonia is the same kind of ownership. It's owned by a philanthropic foundation. So what we can do with a long-term thinking. And that's also why we invest so much in the research, understanding the issue of tomorrow. This is Henning Larsen. We are born out of Denmark, Copenhagen, a Scandinavian and Nordic company, but we have studios across the globe. Just established last year in Sydney, in Australia, but also present in the US and Germany and in Singapore. We have a strong landscape team in Singapore. This is what we do. You can see there's a lot of green and brown colors here. It's because most of what we do is connected with landscape. We don't see our building as like monolith or like standalone in the cities. We are very much connecting with the surroundings and really around the nature. And then the brown color indicates there's a lot of biogenic timber in our construction. But Henning Larsen, we are heading architect, landscape and urbanism, and we don't see it as three different disciplines. When we do design, we have competences on the landscape, within the architecture, and also around the urbanism. So again, when you talk about a Henning Larsen project, it's not about the design or the form. It's of course about creating design excellence, but it's much more about understanding the context and the culture and where we design and who we design for. We have 3 design drivers. The center one is about design excellence. It's about long-lasting design, something that we can be proud of not only today but also tomorrow. Then we are driven by sustainability and circularity. And then the right side, Jay mentioned data. That is my right side of my mind. Right side of my mind, the data and the nerdy part. First project I want to show is just like it's the world of Volvo. Maybe some of you know the Ferrari world in Milan. This is the same in Gothenburg in Sweden. So if you ever come to Denmark and you need to visit the Nordic, you can take the train from Copenhagen to Oslo, and then you go through Gothenburg. This is the new experience center for Volvo. And in Sweden, they have what they call alleemansret to nature, is what right to nature. So no one can own nature. So when you build on a building site, everyone is allowed to go there. This is the same with Volvo here. You can go and you can walk around. You can go up to the roof. But if you need to go in, you have to buy a ticket. This is the highway connecting Oslo and Copenhagen, and where you drive through and see the lighting colors of the world of Volvo. It's designed as 3 big mushroom columns with the 3-dimensional glue lamp structure. The scale of it is quite crazy. This is during the construction process. It opened up this last year, autumn last year, so it's quite new. But it was really fascinating to see how this structure came up and part of the design. And what we did also, especially for my team, was to work with it on a computational design workflow. Is just meant that we were very much in dialogue with the suppliers and manufacturers up front, that we didn't design something and ask the engineers or the manufacturer to construct it, but we understood, working with the Austrian VHAG, on what is the dimension and how could we manufacturing the glue line beams, and then we brought that into the design and built up a parametric model around it. So our design drawing was also the manufacturing drawings in the end. And again, why timber? Mainly because of the CO2 reduction. That's why, and that's how our industry are driving. That's how we are driving the choose of materials when we look into biogenic materials. This is just a very, very overall look on the main superstructures. On the left-hand side, you can see we have a negative 1.2 tons of 15,000 tons of CO2 reduction. Then we have the comparison with the reinforced concrete and the steel. Of course, we use less materials when we go to steel and concrete, but the CO2 reduction is embedded in the biogenic materials in the upfront emission. I will come back to what is upfront and what is embodied carbon on and the whole life scenarios later on. And one of the beautiful thing about wood and timber is that it's not about only the numbers, the CO2, it's also about the feelings and the atmosphere. This is on the right-hand side. This is Philip, our design director, and he went down to Austria VHAG, and I have never seen like a design director hugging a concrete or steel beam, but he was just, you can see on his face, he was just so happy to see that beam coming up, that was the mock-up, that he was hugging it. Introduction, there was also mentioned Felleby. Felleby is a new city, a small city developed next to Copenhagen. We have been the master plan designer of the city. This is the first full timber coming up in Denmark. And it's designed as a village. It's not designed as a downtown global neighborhood. It's very much in a human scale. Maybe some of you can recognize this image or see the reference for this image. Maybe some of you have been to Copenhagen, to the Christiania. It's the free city in Denmark, and in Copenhagen. It's the same kind of atmosphere we want to design here. Something that is self-grown, something that is in eye level, something where people meet people. And we have different architects working with different structures, different design within the master plan, but it's all within the framework of the master plan and the dogma of designing with full timber structures. Here you can see Felleby in the center with the ring around it, and it's very much connected to the downtown Copenhagen that is up north. So it's one of the last green areas that it's right next to the metro and the infrastructure. But you can also, if I zoom in, it's about like connecting green and urban. And we had that idea of taking a traditional city block that the Copenhagen is built around the city block, where you have the private in the courtyard and you have the public on the perimeter. But here we want to combine that with a village structure where you have the central plaza, the pond, and make that new type of topology that open up to the nature, but have an edge to the quarter or to the plaza and the center. And instead of designing a full master plan that was just uniform, we designed 3 kind of small villages with one plaza in the center, and then it opened up. And that's also how we structured. At the moment, we are constructing the one in the top right-hand corner, and then we go to the next one, and then we go to the left one. And there's around parking, there's a parking structure when you come in, but you have to take your bike or your walk to your apartment. Of course, you can come around as a fire entrance, and you can also have drop off, but not every apartment have a dedicated parking place. Again, it's very much connected to a bike cycle network and the metro line. Here's one of the early mock-up of one of the neighborhood, and you can see that the ring road there, the nature around it, and the blocks that steps down and open up to nature, and we let the nature in. It's very much on behalf of nature. We have promised to deliver 10% higher B&D biodiversity net gain. That means that we, of course, take out some green area, but we provide green area with higher biodiversity, a higher habitat quality. It's also such, if you buy or rent an apartment here, you are not allowed to bring your house cat. No cats are allowed because they are chasing the small birds and the mice. So it's like, it's not only something that we design for, but it's also the premise of nature when you move in here. And you can see all the roads and the pathways are lifted. It's also to be resilient. So when we have heavy rainfall, it can be absorbed by the landscape, and it will like it's not like it's another drainage system or pipe. It's open water resilient management. And here you can see this is from the last week where the structure is coming up. The first resident will move in this summer. It's all built on in timber, and most of it is with prefab. So we do prefab elements like those container blocks here, and we ship them and we put them to like Lego blocks and build them around that. But you can also see there was really much diversity in it. So it's like, it seems like very randomly, but it's actually broke down to Lego blocks, and you can build it offsite and you can transport it. That's make also that is like we also have low income family homes here, so it's about keeping the prices down, keeping the buildability up. So that's how it's planned, and that of course the image we imagine in the end, that you will be connected with nature and you will live close to nature, but also in a new community next to Copenhagen. This building is also ongoing. This is the largest timber building coming up in Denmark at the moment. It's called the Marble Pier. It's in the harbor front of Copenhagen. It's a hybrid structure. We have concrete cores, and we have slabs, beams, and the columns with glue lamp structure. And the good thing about this, and this is also coming back to data, this building was designed as a concrete building. We won this competition, I think 5 or 6 years ago. And at that time, we designed it as a concrete because that was in the industry. But the good thing was that the client came back to us and said that they have difficult to find an anchor tenant, because the anchor tenant that they were looking for want a more sustainable profile for it. So we, together with the client, we decided to reshape or redesign the structure from a full concrete to a hybrid predominant timber building. So we have data, we have a full Revit model of both, so we can compare apples to apples here. And if you look at the upfront embodied carbon, is only the superstructure, that means what is above ground. We have a reduction from the concrete to the timber around 8,000 tons of CO2. That means that we have a minus on the timber because we have the carbon sequestration in the biogenic materials that overweight the concrete cores, and the steel structure that are supporting. The red lines are steel structures that are supporting. If you look at the whole embodied carbon for the whole structure, that include basement, envelope, then we have not a negative, but we're having again the reduction of the 8,000 tons of CO2. And we have around 3.7 kilograms of CO2 per square meter per year. This is a number I will come into later on, but this is defining how you get building permit at the moment in Denmark and the new regulation. And then if you look at the end of life scenario, it's balancing out. That is how we are calculating the life cycle of the building, the carbon life cycle of the building. There is an end of life scenario where you have the biogenic materials will be releasing the CO2 in the C3 and C4 phases, so that balance up. So that's what also we are looking very much on the embodied, the upfront emission, and the whole end of life scenarios, and of course the operational. And I said in the introduction that this is not only timber and wood. It's a hybrid structure. So we have the base and the foundation in concrete, and the cores is also very much around both stability in the building, but also fire regulation, fire safety with the concrete cores. It can also be done we're doing a residential building just next door now where we do CLT cores. And then we have substructures in steel, and that's also because this design was designed as a concrete building, and when we transformed it into a timber building. Of course, timber, as you saw with the Volvo case, that they take up more mass. The beams and columns are bigger. So we have this hat profile, so we kind of hidden the beams so we can have the HVAC, the ductwork going through without compromising floor to ceiling height. But these are quite, it's like fridges coming down. They are 60 by 60, those beams coming down. So again, it's also when we work with those kind of structures, it's very much about space planning and space layout. That is the first thing we look at, how to space layout this open floor spaces with because the columns and take up more space than they do with a steel or concrete building. But one of the good things is that the building site was more quiet when they came above ground. That meant that they could actually work in the weekend. Normally, every building site in Denmark are closed in the weekend because of noise pollution for the neighborhood or the neighbors that live next to the building site. But this site, because it doesn't have any steel wheeling or concrete piling, that then they could work in the weekend also, putting together the timber structure. Next project I want to show is more on the use of biogenic materials in an alternative way. This is the Sundby School. It's a primary school in Denmark also, and it's the first school where we have attached reed facade. And the inspiration comes from the local community. The traditional historical building have a touched facade, not only roof. Maybe some of you have seen roof structure like this in the north part of Germany, but also it's very traditional in Denmark. But this one also in this part of region, they also have the facade. So we thought that maybe we could be inspired by that and use the technology and the craftsmanship that was also in the local community. And here you can see that the craftsmen are attaching the facade. So we have a facade where we have the wind barrier on the inside, and the attached is exterior cladding. It have a lifespan around 20 to 30 years. We are expecting 25 years when they need to be retouched, recladded. You see, this is how they're working, and there's a lot of leftover waste product. But again, it's not any. It doesn't have any impregnation. It's not chemical treated. It's purely natural. It's having those stored. They are water resilient. So all leftover product we just put in a container and then we put it out in the nature in the field as fertilizer or for soil. So there's the leftover product just go into a circular system with nature. Again, a lot of people ask about fire. Yes, reed straw can burn, but it's actually not that flammable. This is the fire test that we were doing with the Danish Fire Institute. And here this is a wind blowing. You see the wind cannon on the right-hand side. So we blow wind across the facade horizontally, and then we see the spreading of the fire. You can see also the clock. Now there's almost 6 minutes, and it's not really spread. It's not like just like paper firing up. It goes quite slow, but again, it's also something that is a risk and something we had a very serious dialogue with the client, and we did this dose mock-up. We invested in dose mock-up, and we did a lot of theoretical exercise, but we have difficult to understand what should be the fire strategy, and it ended up that we actually went down and talked with the local fire brigade, and they told us that their fire trucks could spread water from 10 meters to 10 meters on the other side. And then we decided to put in fire barriers, vertical fire barriers with every 20 meters along the facade, because then the fire brigade could come there and they could manage the fire within the 20 meters. So that was part of the fire strategy. Sometimes you need to do a lot of technical, but sometimes you also just asking the fire brigade, how big are your fire truck, and then you find a solution. And this is what you have the courtyard in the center where it steps down, and you have the attached facade towards the fields, the connection to the surrounding, to the nature. So why so much talk about wood and straw and biogenic materials? In Denmark, we had an organization called Reduction Roadmap, and it was not a political organization. It was driven by the industry. It was industry partners, a small group that became a bigger group. And it was across manufacturers, across architect, designers, engineers. We all said that we can do better, and we will need to do better. So it was a political pressure from the industry to put up carbon targets on new builds, and put up a roadmap for it. And it all started without that we want to be within the safe operational space, within the planetary boundary. We need to reduce our carbon emission, especially on our new builds. So there was done a lot of exercise of what we do today with our housing and what we need to do in the future. Where do we need to go? Around today, we spend around 480 kilograms of CO2 per square meter on new builds in upfront. And we need to go down. It's like a huge reduction if we want to be within the planetary boundaries, around down to 20. And if you look at the kilograms per square meter over a year, in Denmark, we calculate over a 50-year lifespan of the building. We are around now, the building that were constructed before was around 10 kilograms of CO2, and we need to go below 1.5, 1.4. So we have a big challenge in front of us. But this actually was a push for political actions. So last year there came out new requirements for CO2 calculation for all new builds. There's a limit. You cannot get a building permit if you don't document your total life cycle, the carbon life cycle of your building. And it's divided into those typologies. So it's also for small building, vacation homes, and around residential and office building, that is the minority, is around 7.5 kilograms of CO2. And then we have a limit on the construction side, with the dotted line in the bottom. The 7.5 is what we do on the building. That is the operation, the energy that the building, the concrete and steel and timber that go into the building. The bottom one, the 4 and 5, is on the construction, the carbon that it takes to transport the material from the manufacturer to the building site, the machinery on the building site. So also what we see today, there's a lot of electrification on the building site that also benefit lightweight structure as timber. So not so much diesel engine, and everyone needs to calculate the amount of diesel they use and the amount of electricity that they use on building sites. That's mandatory now. So this is the standard today, and then we know next year there will be even more ambitious standard, and in 2029 it will be even more, and hopefully there will be a standard coming after that, and hopefully we can go further than that. But is that ambitious enough? This is regard to the IPCC report. This 7.5 is actually, we can barely call it sustainable. We will still emit carbon. We need to go within the planetary boundary, as was listed before. We need to go low, below 0.4 kilograms of CO2 per year. So that's like, it's a long way there, and we need to act quite fast. How do we do it in Denmark? This is the LCA life cycle assessment of a building. In Denmark, you need to take into account the product phase and the construction phase. That was what I described before. You need to document those two. Then the in-use phases, you need to take into replacement. So if you have windows with a lifespan of 25 years, you need to calculate them in twice in the CO2 calculation. Then you have the end-of-life scenario, the waste processing and the waste disposal. As I said before, that is where the carbon are released again from the biogenic materials. Then you have the operational energy, the energy consumption, the electricity, the district heating that goes into the building. And then you have the opportunity for the beyond building life cycle. If you use reuse element, we recover, then it counts 0 in your calculation. So if you have reuse concrete slab that already emitted their carbon and you reuse them in the building, you don't need to calculate them twice. They will be calculated as 0 emissions. So that also very much push the industry for circularity. Why so much focus on the embodied carbon? It's because the Denmark, the grid is green. We have seen a lot of offshore wind farms coming up. That means that the emission factor in the grid is low, is almost like 0. So when we do a carbon calculation, it's almost like this, that 90% is what is in the building materials and 10% is operation. It's very different when we go to UK, Germany, other countries. It's very much about how the grid is put together. Here is an image of the grid and the carbon emission related to the grid 2 days ago in Denmark. You can see almost 100% is carbon free, 94% is renewable. And looking at New Zealand, I just have a quick look at New Zealand. It's almost the same. You also have a very green grid, mostly because of hydro and geothermal. You had a bit of natural gas in your grid. But your neighbors, I think that maybe there's also been joining people from Australia here. That's a totally different image. So a lot of focus on the operational carbon, the energy in Australia to reduce because there's a lot of coal in the grid in Australia. So again, when we look at design strategy, this is something that we look at the first. What is the grid? What is the infrastructure? What is the approach here? It makes much more sense in Australia to look at reducing energy consumption, integrating renewables that it does in Denmark and New Zealand. But what is carbon? Maybe some of you know, Scott, this is, I think, a few years old. You should not be afraid of it, but I think it's a bit wrong. I think we should be afraid of it, and we should take it seriously, and we need to understand it also, because carbon is in everything. Is what we consume, and is what we build. And one of our PhD candidate was studying carbon. It's like almost 4 or 5 years ago, and he was talking about carbon, and no designer really understood what he was talking about. It was a lot of numbers, and there was a lot of these life cycle phases, and then on the way out of the door after 3 years, and he went to the postdoc position. He drew that triangle on the right-hand side, the building material pyramid that he created together with the university partners. And it was inspired by the food pyramid. I think maybe some of you, that is all Danish kids know the food pyramid, that you have to have the rye bread, the potatoes, the cucumbers at the bottom, then there is the red beef in the top. It's the same with the materials pyramid. You have the biogenic materials that have a negative in the bottom. That is the A1 to A3 phases, and then you have the aluminium and steel in the top. And again, related to 1 kilograms of CO2 is equal to producing 3 cucumbers in a greenhouse in Denmark, and it's also equal to 1/4 of a grilled chicken. And it can be related to windows. So imagine how many cucumbers there are in a window like this. Is 2 layers of aluminium standard frame window, and also a steel beam and a stone wool insulation bed. And again, there is a dialogue about capturing carbon, but it's quite expensive. If you need to capture carbon from the carbon capture that was in Reykjavik in Iceland, you need to pay around 400 euros to capture a window like this. So the investment is definitely to reduce and not to capture. Inspired by the material pyramid, we had a look and say, what can we do here and what can we do best? And then we looked at the right-hand corner, saw straw. Could we build something out of straw? That then inspired us, and that we went into a research project with a small school. This is an extension of a free school in Jutland called the Feldballe School. And the idea here was, instead of fulfilling any building regulation, we had a client that said, I don't want to look at building regulation. I want to look at what makes sense for nature and for the people. So we decided to build a building without any mechanical ventilation systems and with full biogenic constructions above ground. And we set up some dogmas. Maybe some of you have seen, it's 15, 20 years ago, Lars von Trier, the dogmas. That was the same here. No building regulation, but only dogmas. Use of bio-based materials, designed for disassembly, good passive indoor climate, free of toxic chemicals, as much reuse, local reuse as possible. That was the dogma we set up, and that was this design drivers. And then we looked at the straw, and taking a small handful of straw would have a negative carbon impact. Again, straw is like, I think Daniel, we're also going to talk about biodiversity and how things are thought in a circular process. Straw is a leftover project from agriculture, and left-hand side is from NASA. It's not wildfire, it's actually active fire. People burn their fields, and imagine, instead of burning some of this straw, maybe we could use it as building materials into construction. So that is the ambition. And we teamed up with a company called Eco Cocoon that do those mass manufacturer store components. Again, it's like Lego blocks. They are prefab element, and then they are screwed together on the building side. And this is Magnus and Peter, the two design architects that were working on the project, and they were also working with the constructors and on the building side and sleeping in a shelter with them, and really try to understand how to put a house together built out of straw. And this is the section. Unfortunately, it's in Danish, but this is like we take it from outside in. We have some wooden cladding. Then we have a ventilated cavity between that. Then we have the wood fiber board insulation. Then we have a wind barrier, and then we have 400 millimeters of store element. And then we have the clay cladding, no gypsum, but clay cladding on the inside. Very basic. And here you can see the outside, and here you can see the inside. We have an upstand. You can see on the where we have all wiring, electricity going, also to protect the clay cladding. Clay is a bit more vulnerable than gypsum are, so that is like you need to rethink that into the design. And this is about seagrass, no mechanical ventilation, purely natural ventilation coming through the facade and going through opening windows in the top. It's a smart system, so we have CO2 sensors that open and closes the window. And through those lamellas, you can see in the pictures, there's a window. There's a small what you call opening behind that is mechanically controlled. It's like the mock-up is in the right-hand corner, and we have a eelgrass filter in it, so it filters the air coming from the outside, mostly for noise and for heavy particles. And if you want to change the filter, you just open the lamellas, and then you take out the filter, and then you go to the shore and collect some eelgrass and dry it up and put it in again. It's not treated at all. It's have a very salty content, so there's no insect living in it. So that's quite basic. But again, I said no chemicals, and that there is next to it. That's a chemical class, and they have ventilation there, and we try to measure the chemical content, but the kids move in before we actually could measure it. So that was a bit of fun. But again, scaling. This was only a 250 meter small school. The next building we built in straw is 100 and almost 150,000 square meters of school. The logistics center in Leidenstad in Holland is for the bestseller client. It's a logistics center that both have high bay for storage but also distribution. It's coming up now. It started design 2 years ago. It's together with our partners from Ramble and Dutch main contractor. It's based in between Rotterdam and Amsterdam in Leidenstad. It's very much next to the shore. It's a lowland area. So again, a big focus on the biodiversity. Here you can see this is the main entrance. This is the right hand where people come in from one side through nature, through the forest, and then the infrastructure come in from the back side. Then we have the terminal building that is 500 meter long, with a lot of mechanical distribution, and then we have the high bay, the storage area on the back side of it, and they are fully roof with green facade and with PVs on the roof. So this is the rendering that it look like. This is the main entrance. Again, we're measuring the biodiversity. We are building on the site, but we are improving the biodiversity to integrating wetland, green roof. You can see the wetland with the boardwalks. The green roof where the employees have access to roof terrace, and there's only one entrance for the management and for the orange shoot. Everyone goes in through the same area. Everyone have access to the same cantina. Everyone have access to the same facilities. This is on the back side with the high bay, the green facades. Some of the image. It seems like very beautiful image, this one, and also this one, but it's actually happening now. This is the terminal building, 500 meter long, fully timber glulam structure. And this is from last week. I didn't put the music on, but this is the what you call the topping of the building. Coming back to the straw, as you saw, as the Feldbälle project, the facade, the insulation was this straw paneling, and we do the same here. So we have a build up from the upper floors where we have wooden cladding, and for the ground floor where we're having aluminium cladding. But it's all with the straw element inside the build up around the straw element. And it comes like those pre-manufactured elements to the building site. They come like this in trucks, very flat packed, and then on the building site they are cladded in, and then they are brought to the main structure and mounted on the main structure. So very basic system. And here you can see some of the mock-up, some of the one from the upper floor where we have the wooden cladding around it. I actually don't know the manufacturer of the wooden cladding. Maybe I should have known that, but maybe we can have that, Daniel, in the discussion after. And then some of the detailing of it. And here you can see the scale of it. It's huge when you're down there. 500 meters is long. And the high bay, this is a working drawing of the high bay, and you can see this is inside. They're enormous. But imagine all this is straw. Cut a small hole in it, and you can see the straw just inside it. It's quite significant. And they're mounting around 200 square meters of straw facade every day. 3 people, so it's like very fast. Last thing, I just want to share something with you where you can get access to all the details that I showed today. We just launched what we call Open Detail. It's a web-based portal where you can get access to 3D and 2D drawing. You can also upload your own drawings, but it's based on biogenic materials, so it's only biogenic materials that are there, and it's free for download. So you can look up different projects that we've done with some of our partners, and you can get access to the details 1 to 5, so you can download it as a PDF. You can integrate it into your BIM model. We also have CO2 data on it, and we're having EPDs on all the product that are used in it. We will share this presentation after so you can have the direct link to it and test it out. But this is just some of the detailing you can find in there to use it out in the project that you're working with. Then we also have the carbon catalog, both from interior and exterior cladding that's collecting EPD data from the manufacturer, but just put them into a system where they are per square meters, where they are comparable from different manufacturers. And you can see, looking at bio-based boards here that having upfront negative carbon impact compared with more mineral-based boards. Sometimes it's just a decision choice when you do the spec on your building. But we have this catalog where you can filter through. There are links to the manufacturer. You can see the EPD numbers. We're having manufacturers calling us every day to get their data in, because this is also very much pushing the industry to deliver better on the EPDs. But again, summing up, the window is closing. If we need to be within the 1.5, I think 1.5 is something that we talked about yesterday. Now is 2.0, so we need to act fast. And it's of course the long-term thinking, but if we need to reduce here and now, the biogenic materials is the first and foremost driver for it. So that's also what you see. Most of our new build coming up in mass timber structure with biogenic materials insulation. If we don't do that, we do very much into transformation, adaptive reuse of the existing structures. I think that was ending up with some few words. Thank you.
Jakob, I've never heard carbon measured in cucumbers before, so thanks for that interesting insight.
Yeah, and what should we do in New Zealand? Is that cucumbers are...
Yeah, maybe I'm going to steal that idea. That's great. Jakob, there's been quite a few questions come through on the chat. So I'll start with some of those. Ellie Perkins is asking about she's interested in hearing the use of the modular construction that you applied in the Faileby project. And she wondered if that helped reduce the embodied carbon further compared to building on site.
Yeah, it did. As you see, also a lot of the building that we do on site is hyperstructures because the joint between different elements is important, and they are difficult to do they can be done, but they are difficult to do in biogenic materials. So by doing it prefab, we get all the structural built into the prefab element, so we can reduce some of the carbon related to the joints and to the build-up. So that supported us, and it's also supported us in what I said, the 5 phases that is on the emission happening on the building site. When you do it in a closed environment, you are much more efficient with your machinery and compared to building on a building site, and all the protection, especially you need to protect a lot of the structure that we do on site in biogen. We have a big tent around it, standing under a big tent to be well protected in the winter time, so that you avoid that with doing the prefab.
Yeah, great. Jumana Hassan has asked, firstly, thank you for your insights, and she wants to know if you have a standards or internal standards or strategies catalog that you would normally go with when designing buildings. And I'm guessing that's what you showed us a bit earlier, but I'm sure at Henning Larsen you've got your own internal models and standards that you refer to. Is that something that you have in-house as a business?
I would say no. We operate, Daniel, very globally. So we really want to understand the local context before we actually start designing. So some of the things that we do is to do an early life cycle assessment on the local content to understand where is the emission, is the operational, is the upfront, is the end of life scenario, and then we rely on manufacturer like you, Daniel, to provide us with the EPD data. That's mandatory for all our projects to be able to the manufacturer to deliver data upfront, and we also specify it in our specs. We do carbon budget. So we don't do a calculation when we have designed a building, we do carbon budget. So when we are tendering out an envelope or a structure, the contractor that we are contracting with have a carbon budget to operate in. So that is like, it's not something that we define by ourselves. It's a partner, it's the value chain we need to facilitate. So we see ourselves more like the facilitators in meeting the target, because it's not only the architects that can be standing and screaming around that it need to be one only solution. We need to be open for that. So we operate very much with carbon budget, and we also translate the ownership to the partners that we work with.
Yeah, I think that's interesting, and a lot of the viewers from New Zealand or Australia, the whole concept of carbon budgets that's not something that's really happening here in New Zealand and Australia. I think that's something we expect to come, but it seems that in Denmark, you guys are really pushing that hard, and it's interesting to see as a glimpse into the future that what we might start seeing in New Zealand and Australia. I've got another question from Susan Yap, who's asked how challenging it was to get authority approval from the fire department for the straw bales. How difficult is that?
To be honest, it was not that difficult for the fire, for the municipality. It was more difficult for the insurance company to convince them, and that's why actually what we see. A lot of the biogenic material can be documented into fire regulation. The straw element have a 120-minute fire proof. So the difficult part, and that's what we tell our client, you need to talk with your insurance company first. We need to bring them on board. And often that is also this misunderstanding that the fire brigade or the fire authorities care about people, the insurance care about value, and there's a totally different way of seeing it. So we don't see any big barrier. In Denmark, we are building, you saw the building up in eight stories with full timber, big barriers for fire. For the regulatory part, we see biggest barrier is around the acoustics, both thermal and acoustics, but mostly acoustics. The sound transmission from one floor, from one apartment to the next apartment, that's where we need mass in it now. So we do some building where we actually challenge the acoustic requirement, especially for the big timber you saw, the marble pier, the marmormålen, we have 8 centimeters of concrete on top of the CLT slabs. And that's purely for acoustic reasons. That's not because we would like them from a structural reason, it's purely from an acoustic reason, or for a fire, it's acoustic.
Yeah, I did have an initial thought when I saw some of those designs, these wall sections of 60 centimeters, or we refer to it as 600 millimeters. It's a big wall section, and you lose quite a lot of square meters when you build with wall sections that big. Is that come into the design equation?
Yeah, but it's like this is also one of the barriers that will be difficult to build like a store building on Manhattan because of the you're missing a build area or lease area. But in Denmark, you're calculating the inside, not the outside. So that benefit in Denmark, that it's not, you don't need to pay taxes for the wall. You only need to pay taxes for the inside of the building. So, but I know country by country this is different. But it takes up more space. That is one of the barriers. It's not so efficient. The 400 millimeters of straw insulation is equal to 220, I would say, rock wool or stone wool insulation. So it takes up more space. But for the logistics center, that was a minor thing. That was not the driver for it.
Yeah, no, that makes sense. I've got a personal question. I raised this with you earlier. What I'm interested in personally is the fact that I think we accept carbon needs to be built and considered. Both operational and embodied carbon needs to be considered in the built environment. And I think biogenic materials like straw and wood is the obvious way of doing that. What I'm interested to understand is if you guys are starting to give consideration to not only the carbon sequestration benefits of biogenic materials, but also the possibility of those biogenic materials to create improved biodiversity, because we know carbon's a problem, but we also know biodiversity is a problem and growing problem for the world. Do you have any thoughts on that?
Yeah, I fully agree. This is one of the concerns, Daniel, we need to look into. We're having a PhD project ongoing about off-site biodiversity. So it's not only what I talked today is very much on-site, but we don't take care, like for the bestseller project, we are harvesting a lot of timber, mainly from Austria and Sweden. And we need, of course, to take into account the forest industry in that. But the main problem now in Denmark and Scandinavia is not for the construction, it's a minor. I think it's 2%. The thing that we are using the biomass for is like for firing up our energy plants. So that is the big thing we need to discuss here. It's not the construction industry that consume, but we need to do it right, Daniel, of course, when we use timber. And we also know that when we are cutting a tree, the roots is there and they will emit carbon. We need to take the whole thing into account. We need to do clever foresting, and we need to, I think you mentioned, there was something I read on your homepage that you also advocate for leaving some of the forest for full natural habitat instead of using like heavily for forest industry. But to be transparent, and it is something that is difficult to measure at the moment, but something we need to take into account, something we have a dialogue with the manufacturers on. Where does the wood, where does the timber come from? How is it harvested?
Yeah, no, I agree with that. Look, Jakob, there's a few more questions, but there's a bunch of people that have come back and said they're really impressed with your presentation. Very inspiring, amazing presentation, extraordinary, thought-provoking. Those just some of the words that I've seen come up in the chat. So, hey, we really appreciate you taking some time. I know you could be working on an amazing project, but instead you spent 45 minutes of your day showing us and inspiring us what the future may look like. So thank you so much for spending your time, and I look forward to seeing the next bestseller. The next bestseller needs to have a Abodo on it.
Yeah, they will have a Abodo on it. Daniel, I think we should be both working on that. And also it's a Friday, so I'm happy to share, and everyone that now is Friday evening in New Zealand and Australia. But if you wake up Monday morning, please feel free to reach out, and we will also be happy to share the presentation. So a lot of good ideas, research project opportunities. Daniel and I'm here to work with you, and it could be good, Daniel, to have a first Henning Larsen project in New Zealand with Abodo on it. Definitely cross my fingers for that.
Yeah, me too. Thank you so much, Jakob. That was awesome.
Take care.
Bye-bye.
Wow, team, that was absolutely awesome. When you get Jakob from Henning Larsen and Daniel from Abodo Wood in the room together, that's where the magic happens. It's just wonderful to see how passionate you both are about creating a better built environment. So thank you, team. And thank you to you guys for tuning in. We really, 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 really appreciate it. It's great to have you here. And as you know, Abodo Wood is really passionate about providing educational content for our architectural and design community. So we'll be back soon with another CPD webinar for you. So stay tuned. And until then, catch you later.